Hi, it's Mr. Carson, and I thought we'd better go through this before we get too far into the year with science. Sometimes when we are doing things, we forget to tell the person totally what we're talking about. And one of the biggest problems we have is when we don't tell the person what a measurement is really about by including units. So I thought we'd go through this very, very quickly and just do a little bit of a session on why units are important. Units are things that tell us what you're measuring. And in your science classes, you are going to be constantly measuring lots of different things. So we don't necessarily want to talk about amounts of things anymore. We want to talk about specific things like the volume of something, or the mass of something, or the time taken to do things. And then the temptation is to just leave it as a number, instead of telling the person what the number really means. So if you've got 701, if you don't add the units, we really don't understand. The readers don't understand what we're doing. And it is a comparative thing. We should be able to compare certain things we're doing. So it's super important, if we're doing a big experiment, that we have the units constantly put in there. So every time we do a mathematical calculation, or every time we do a table, or a chart, or a graph, it's super important that we include the units so that we fully explain what we're on about. Now, ages ago, about 1960s and 1970s, the scientific community went to the SI data system, and what that basically has is we offered certain things as being a units. We decided this is going to be a unit because so many different countries around the world had so many different units. And so when people were talking to each other, or when people were trying to replicate experiments done in another country, they couldn't do it because the units were different to what they were grown up with, or they're different what they expected. So overall, science decided that we were going to have a standard set of units called the SI units. And as we see over here, we see there are certain things. We've got a base unit, a quantity being measured, and the abbreviation. Now, some of these we don't touch until later on, but the ones I'm going to look at are the ones we need you to concentrate on. We measure lots of length, and the standard unit is the metre, little m. We do lots and lots of mass, and the standard unit of mass is not the gram, but the kilogram. And this was all decided by the scientists at the time, that this was going to be the best thing to do. Obviously the standard unit of time is the second. And even though we're down here, scientists use 2 or 3 different types of temperature scale. And we normally use Celsius a lot because it applies to everything around us. It applies more to our natural life. But the Kelvin scale came in after that, and we can see there are other ones here with it. Now, don't be frightened if you don't understand what a mole is. Don't be frightened if you don't understand what a candela is, or an ampere. We'll cover that during the years, but it's something that you need to include in your thought process. So as you can see, it's very, very important when you are communicating that you use units, and we try to use the standard units. To help us, we actually came up with this metric conversion scale, and it's all based upon tens. So when we do tens or multiples of tens, so if we go to this side, as we get bigger, bigger's at the top, smaller's lower down. And it's got a factor here which I'll go through at some stage in the future. Mega is like a million. So if I go from a mega something to a kilo something, I'm talking about a difference of 1,000. So a mega is 1,000 times bigger than a kilo. But then we've got these little ones in the green areas through here. We've got kilos to hecto is only 10. Hecto to deca, again, 10. And then to the unit is 10. So this means that going from a kilo, so like a kilogram or a kilometre or a kilometre, to a gram or a metre, then we find that we have a difference of 1,000 also. Then as we get smaller, we also use this. So 1/10 of a unit is called a deci. So 1/10 of a metre would be a decimetre, 1/10 of a gram would be a decigram. Not very often used. Then, if we go then to the centigram, again we're doing factors of 10, 10 times smaller each time, and back to a milligram. So again, between a milligram to a gram, or a millilitre to a litre, or a millimetre to a metre, we are dealing in the factors of 1,000. Then we jump to bigger ones again. If we go to very, very small, about the size of bacteria and cells, we go into 1,000 times smaller again. So this means that going from a unit like a metre to a micrometre, we do 1,000 and again another 1,000. So that means 1,000 times 1,000, or 1,000,000 times smaller. And then at some stage you are going to deal with light, which is dealing with a nano. And it again is 1,000 times smaller than a micro. So that is 1,000 million of them lined up end to end would correspond to 1 metre if we were talking about nanometers. So we've got to learn how to do this and how to convert between them. So let's have a quick look at some problems and work out from there. Right, we're going to look at a change of millilitres. How many millilitres, or millimetres, sorry, are in metres? So there's metres here, and there's millimetres here. And we see there's 10 times 10 times 10, or 1,000 times difference. So when we change from metres to millimetres, we are obviously going to have a bigger number. So what we're going to do is multiply by 1,000, the difference. So we're going to have 2.5 times 1,000, or 2,500 millimetres. Now notice what I've done is I've moved, the easiest way for us to think about this is moving the decimal place. I've moved the decimal place 1 from here, 1 place, 2 place, 3 place. So I've moved it 3 places to the right. Move the decimal point 3 right. So now what I've got is another example. So I'm going to find out where these things are, and I'm going to work on my blue. Here is cms, here is mms, or sorry, meters, and there here is meters. So we've got to go from cm to m. We have to, because it is going to be, there are 100 cms in a m, this time we have to divide by 100. So it becomes 21 divided by 100 equals 0.21 metres. In this time, I have moved, when I divide, I move the decimal place to the left. And was dividing by 100, so that means I divide it, move it 2 decimal places to the left. So I move decimal point to left. Alright, it was here. 1, there it is there now. So I've moved it that way, then I moved it that way again. Right, let's look at another example. I've talked about metres and kilometres. There's kilometres there, there's metres there. So I've got a factor of 1000. Alright, so I'm converting from little to big. So from metres, or from kilometres, sorry, to metres. I'm moving big to little, so it's multiplied by 1000, or decimal point 3 right. So I've got 1.4 times 1000, or 1400 metres. I hope this is making some sense. Now, doing the reverse conversion, I'm going to go from metres to kilometres. So if we multiply coming from kilometres to metres, we divide by the same factor, which is 1000. So that means my decimal point goes this times 3 left. So we've got 25 divided by 1000, which is 0.0. I've got to move it 3 decimal places. So it's 25.0, so it becomes that kilometres. It was here, so I moved 1, 2, 3. I hope this is making some sense and it's some easier to do. The last one, let's deal with some volumes. Same sort of idea. I want to go millilitres to litres, or sorry, litres, which is here, to millilitres. So I've got a factor of 10 times 10 times 10, or 1000. So I want to do litres to ml. So I'm going to, because I'm going big to small, as I move down I go big to small, I multiply by 1000, or decimal point 3 right. So I've got 12.5 times 1000 is equal to 12,500 ml. Alright, decimal point was there. There's 1, there's 2, there's 3. So now it's over here. Lucky last. A container has 600 mils of milk. That's normally the size container. How many litres are there in this? So I'm going ml to L. So in this case I divide by 1000. So the decimal point moves left. And it moves left by 3 spots, because that's the difference between a ml and a L. So we go 3 left. So I've got 600 divided by 1000, which is equal to 0.6. So 0.6 L. Alright, I hope that helps, and I hope it makes it easier for you to understand what's going on.